Your brain is the most complex object we know of in the universe. Within its 3 pounds of soft tissue, you hold your entire world. It records the sights, the sounds, and the feelings of your life's journey through space-time. But think about it for a moment. You don't remember every single second of every single day. You don't recall the exact pattern of the carpet you walked on last Tuesday, or the precise taste of every sip of water you've ever had. If your brain recorded everything, it would be overwhelmed with useless information. It would be like a library with every book ever printed, but no card catalog. Finding what you need would be an impossible task. So, how does the brain choose? It has to be selective. It must act as a master curator, deciding which experiences are worthy of being kept and which can be allowed to fade away into the background noise of existence. This process is not random. It is an elegant and efficient system honed by millions of years of evolution. The experiences that matter, the ones that teach you something important about survival, reward, or danger, are the ones that get a VIP pass. The mundane, the repetitive, and the trivial are often left behind. Your brain is constantly making judgments, separating the signal from the noise in the vast stream of data flowing through your senses. This selection process is fundamental to creating a coherent story of your life, a narrative that defines who you are. The memories that stick are the building blocks of your identity. They inform your future decisions and shape your understanding of the world. Imagine a star collapsing under its own gravity. It sheds its outer layers to forge a dense, stable core. In a similar way, your brain sheds trivial daily details to forge a stable, meaningful core of long-term memories. This isn't a failure of memory, it's a feature. It's the brain's way of making sure the lessons that will help you navigate the future are the ones that endure. This incredible feat of sorting and storing is not happening in some mysterious, unknowable void. It's the result of tangible physical processes unfolding within specific regions of your brain. Neuroscientists are beginning to map this intricate choreography of neurons, discovering the mechanisms that govern what we remember and what we forget. As we peel back the layers of this biological marvel, we find a story as profound as any cosmic tale. It's the story of how a momentary experience can be etched into the very fabric of our being, ready to be recalled years later. It's the story of how we become who we are, one memory at a time. Deep within your brain's temporal lobes, nestled near the center, lies a structure with a beautiful name derived from the Greek for seahorse. It's called the hippocampus, and it is the master architect of your memories. Despite its small size, it plays a colossal role. The hippocampus is where new experiences are first processed and organized. Think of it as a temporary workspace or a cognitive scratchpad. It lives a fascinating double life, operating in 2 distinct modes depending on whether you're awake and exploring the world or deep in the quiet sanctuary of sleep. This duality is the key to its power, allowing it to both capture the present and preserve the past. During your waking hours, the hippocampus operates in its online mode. As you navigate your environment, learn a new skill, or meet a new person, your hippocampus is furiously at work. It captures the torrent of sensory information and weaves it into a coherent episode, a memory. It acts like a GPS system, creating a cognitive map of your surroundings, noting where important events happen. This is the mode of recording, of capturing the raw data of your daily life. Every new face, every surprising turn of events, every hard-won lesson is initially encoded right here, in the intricate neural circuits of this seahorse-shaped structure. But the hippocampus has a limited capacity. It can't hold on to everything forever. When you go to sleep, it switches to its crucial offline mode. This is when the real magic of memory consolidation begins. While you rest, your hippocampus is anything but quiet. It begins to replay the events of the day, like a director reviewing the day's footage. But it doesn't replay everything. It selectively replays specific experiences, strengthening their neural traces. This offline replay is essential for transferring important memories from the temporary storage of the hippocampus to the vast, long-term repository of the neocortex, the brain's outer layer. This 2-mode system is a masterpiece of biological engineering. The online mode allows us to be present, to learn and adapt to our world in real time without being bogged down by the past. The offline mode ensures that the most valuable lessons from our experiences are not lost. It's a cycle of experiencing and reflecting, of recording and archiving. Without the hippocampus and its 2 distinct lives, your past would be a fleeting haze, and your ability to learn from it would be profoundly diminished. It is the bridge between the fleeting moment and the enduring self. the gateway through which experience becomes wisdom. How does the hippocampus decide which of the day's countless experiences to replay during sleep? The answer lies in a fascinating pattern of neural activity, a secret signal that acts like a bookmark for your brain. Scientists have discovered these signals and named them sharp-wave ripples. Imagine a calm pond. A sharp wave is like a large stone dropped in, creating a massive, synchronized splash of neural firing. This is immediately followed by a rapid, high-frequency ripple, as other neurons fire in quick succession. This whole event is incredibly brief, lasting only about 1/10 of a second, but it's a powerful marker. This process creates a kind of neural competition. Throughout the day, different experiences create different patterns of activity in the hippocampus. During sleep, these patterns vie for a chance to be replayed. The sharp wave ripple is the mechanism that selects the winners. The neural patterns, representing the most significant events, like finding a solution to a difficult problem or navigating a new route successfully, are the ones most likely to generate these ripples and get replayed. The brain is essentially shouting, this one was important." These ripples are the brain's way of prioritizing information for permanent storage. What's truly stunning is the speed of these replays. An event that took you several seconds or even minutes to experience in the real world is compressed and replayed within the 100 millisecond window of a sharp wave ripple. This temporal compression is not just for efficiency, it's critical for communication. The neocortex, where long-term memories are stored, has its own rhythms during sleep. The compressed replay during a ripple happens at just the right speed to sync up with the receptive windows in the neocortex. It's like sending a data packet at the perfect frequency for the receiver to catch it. Even more remarkable is the discovery, published in a 2025 study, that these ripples don't only happen during sleep, they also occur during brief pauses when we are awake. Moments of quiet contemplation right after a significant event. These awake ripples seem to function as the initial bookmark. When you finally solve that puzzle and pause for a moment of satisfaction, a sharp wave ripple may fire, tagging that successful memory right then and there. This awake tag then primes that specific memory, giving it a higher priority for being replayed and consolidated later that night when you sleep. It's a two-stage process. Tag it now, store it later. To understand this process, let's journey into the mind of a mouse. Researchers designed an elegant experiment where mice had to learn a specific path through a figure-8 maze to receive a tasty reward. The scientists recorded the activity of hundreds of neurons in the mouse's hippocampus as it learned the task. As the mouse ran through the maze, different neurons fired at different locations, creating a unique neural signature for the journey. The challenge was to decipher this complex code and see what the brain was doing with it. This is where modern science gives us a kind of superpower. The researchers used a powerful computational tool to make sense of the data from all those neurons. This technique found a hidden structure in the neural activity that perfectly mirrored the figure-8 shape of the maze itself. Essentially, they reconstructed the maze just by looking at the brain's activity. When the mouse would pause, after successfully getting its reward, the scientists saw it, an awake, sharp-wave ripple. And when they decoded the content of that ripple, they found it was a compressed, high-speed replay of the successful trajectory the mouse had just completed. The brain was bookmarking the win. Then came the next phase. Sleep. The researchers continued to record the mouse's brain activity as it rested. They observed numerous sharp-wave ripples during sleep, just as expected. The astonishing part was what these ripples contained. The ripples that occurred after the maze training were replaying the exact same successful maze running patterns that had been tagged by the awake ripples. They were the very same memories, being played over and over. In contrast, ripples recorded from the mouse's sleep before it ever saw the maze contained completely different, unrelated patterns. The experience had reshaped what the brain chose to dream about. This provides a beautiful, clear model of how memories are curated. The awake ripple acts as the tag, identifying an experience as important. In this case, this path leads to food. This tag, perhaps by strengthening local connections in the hippocampus, marks the memory for preferential treatment. Later, during the quiet hours of sleep, the brain's consolidation machinery kicks in. It searches for these tagged memories and replays them repeatedly, strengthening the neural pathways and transferring the information to the neocortex for permanent storage. The unimportant journeys, the dead ends, are not tagged and are allowed to fade. This is why practice, and the rest that follows, makes perfect.